Let's begin. Today's October 19th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 3, 5, 13, 18, and 19. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. Criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A takes a look at our middle digit, the square digit, and compares it to the number 3. So should square be less than 3? Should it be equal to 3? Or should square be greater than 3? Criteria card B takes a look at our first digit, the triangle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card C takes a look at our middle and last digits, square and circle, and compares them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D will take a look at our 3 digits, triangle, square, and circle, but this time it'll add them up, and the Turing machine will let us know if that sum total is an even quantity or an odd quantity. And finally, criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing machine approves of my choice for triangle. I did pick an odd 3. So yes, the Turing machine is confirming that first digit, that triangle digit, should in fact be an odd value. So let's go ahead and type that up in our notes in section B. And we'll say that triangle is an odd digit. And of course, since it is odd, we can go ahead and cross out both of the evens. Okay, so I think the next thing I'd like to test is criteria card D. Okay, so the Turing machine does not approve. Recall that criteria card D does add up all 3 digits. So let's go ahead and do that with my proposal. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, but the Turing machine does not approve of that. So it's actually letting us know that the sum of the 3 digits should actually be odd. So let's go ahead and type that up in our notes in section D. And that is that triangle plus square plus circle should be an odd quantity. And since the overall sum is required to be odd, let's take a look. Well, we're already starting off with an odd digit in triangle. So the 2 scenarios that would end up with the sum total being odd is that square and circle have to be of the same type, meaning they both have to be even quantities or odd quantities. Because regardless if they're both even or both odd, whenever you add 2 evens or 2 odds, that sum is even. And then if we add on to it that triangle odd value, so even and an odd does give us an odd solution. So we're looking at a potential solution that is either all odd or odd, even, even. Okay? And just as a thought, notice that criteria card C does compare square and circle. So that may be a way to perhaps maybe order the two evens or the two odds. That's plausible. Although, let's see. Although we are told, in criteria card A, what that value could be. And so maybe they're not both. Well, they both do, again, have to be the same type. So we're comparing either two evens or two odds. Perhaps maybe it's a way to have them be equal. And somehow square would help us to figure out whether it's, an even or an odd. Maybe. Let's see. So what are we looking at? So, and criteria card E adds up the first and the middle. So, I don't know. Could the sum be equal to 6 with a 1, 5 or 5, 1? Is that possible? Maybe not. I'm thinking that if it were equal to 6, then I don't know, could it even be 3, 3? Not sure. I'm trying to see what would be a good. Let's go ahead and test criteria card E. Even though I don't have a sum of 6, let's see what happens. Okay, so the sum of the first two digits in my proposal 3 plus 1, that's 4, and 4 is less than 6. So yeah, it's true that the sum of the first two digits must be less than 6. Okay, so let's type that up in our notes for section E. So triangle plus square should be less than 6. And what can we conclude from that? Well, if the sum of the first two digits requires it to be less than 6, then neither triangle nor square can be a 5. And that is because if you add 5 to even the smallest of 1, that's already a 6. And of course, if you add anything larger than 1, that will exceed the sum of 6. So, yeah, so you can't have both or either triangle or square be 5. Okay. Is there anything else? Well, we can't cross out the 4 in square because you could still add 1 to it, and that would give us a sum that's smaller than 6. And of course, 3 you can always add to a 1 or a 2 in square. So, yeah, I don't think you can cross out anything. Well, I believe that does it for this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our square digit to the number 3. We also did not test criteria card C, comparing our middle and last digits, square and circle. And, well, yeah, that's actually it. And so let's see. Well, and, even though we got an X and D, we already know the gist of it. So we should be able to construct a 3-digit proposal that, abides by it. We need to make sure that the sum is odd. So remember, our solution should be odd, even, even, or all odds. Okay, so what can we see here? Again, it almost boils down to A and C, comparing the two. I do see a lot of equals, and obviously square could then tell us which one in particular it could be. The most likely possibilities perhaps could be they either are 3 or 4. And the only reason I say 3 and 4 is because if square and circle were both 1 or 2, that would that would have too many possibilities, because both 1 and 2 in square will guarantee us a sum that's less than 6 when we add it to triangle. So that would lead to too many ambiguous solutions. So let's see. 3 or 4. Somehow, let's see. Yeah, it almost seems like everything hinges on square, because square, you're both comparing it to circle and you're using it to find out triangle. So square is very essential. So that's why I'm kind of leaning towards it either being 3 or greater than 3. So we are dealing with, again, 2 odds in square and circle. I'm sorry, 2 odds or 2 evens. And yeah, I'm going to go ahead and I'm going to say maybe square is 3. And it's going to be equal to circle. So that would force triangle to be a 1. So I'm looking at 1, 3, 3. So let's go ahead and try that out. Hopefully it's not too specific, but using the cards, we'll just see. All right. Well, the whole reason for choosing that was, again, it's my belief that square is critical. So let's hope that it is actually a 3. So let's test criteria card A. It is. Wow. Okay. So again, for me, it was a toss-up between 3 and 4. And so let's go ahead and type that up in our notes in section A, that square is equal to 3. And of course, since it is equal to 3, let's go ahead and cross out everything else for square. So it's not a 1, it's not a 2, and it's not a 4. Okay, and because the sum of the first 2 digits needs to be less than 6, yeah, a triangle cannot be a 3. Okay, and now that we've established that square is a 3, that means that it cannot, you can't have an even in circle, because it's either all odd or odd, even, even. And so let's go ahead and cross out the 4. And so let's take a look at this. Yeah, this now it kind of boils down. Well, it could be anything. It could be 1, 3, or 5. Yeah, wow. Well, we'll definitely test it. We can't, I don't think we can deduce. And yeah, if it's not equal, then yeah, we'll definitely have to go to a quick third round. But let's hope that it's equal. This is the one that's really, we'll just be lucky if we get it. So let's go ahead and test criteria card C. Not a 3, not equal. So yeah, so let's go ahead and cross out the 3, and let's type in our notes that square is either going to be less than or greater than a circle. So let's go ahead and say square is going to be less than or greater than circle. And yeah, we're going to have to go to a quick third round. So yeah, it's a toss-up. Yeah, I'm not sure. 135, yeah, they're sort of ascending. 131, you have a duplicate. There's obviously not a card that kind of gives us a clue of either one. So it's a toss-up. So I'll just say 131. Oh, actually, I do have to go to the next round since I did not do 3 tests. So I'll type in N for next. And so now it's actually prompting me for my 3-digit proposal, which I decided for 131. And again, we're going to test criteria card C. Okay, so yes, it's true that if you look at our digits of square and circle, notice that I did choose a value greater for square than circle. So it is true that square should be greater than circle. So let's go ahead and cross out the less than and the or. And so since square must be greater than circle, so let's go ahead and yes, cross out the 5. And so yeah, the solution does seem to be 131. And so let's quickly review. So is our middle digit 3? It sure is. Do we have an odd in triangle? Yeah, it's 1. Is our middle digit greater than our circle digit? Yeah, 3 is greater than 1. The sum of the 3 does add up to 5, which is odd, and the sum of the first 2 is less than 6. So that looks like our solution. So let's go ahead and verify nonetheless. And our solution was 131. All right, fantastic. Now, how do we do versus a Turing machine? Well, we did go to 3 rounds, and there were 5 criteria cards. We did have to test one of them twice, so we'll see how we did. So in the first round, we did B, D, E, and in the second, we did the remaining 2, A, C, and we did C again on the third round. So let's go ahead and type that up. So B, D, E in the first round. So B was correct, D was incorrect, E was correct. In the second round we did A, and I believe C was incorrect since we had to do it one more time in round 3, but we did get it correct. So how do we do? Okay, so we still beat the Turing machine by 1 question. So let's take a look back really quick. I've always sort of been intrigued with solutions, for example, like 131, where there is a duplicate. We do have, there's a pair in our solution, yet none of the cards, none of the criteria cards in the puzzle refer to pairs. So I'm always intrigued when stuff like that happens. And as I mentioned, before choosing 131, there was 135. Also, again, another sort of scenario where a solution could have been in ascending order, but that particular criteria card was not present in our puzzle. So I'm always curious about those sort of interesting scenarios. Again, another good reason why I really like the Turing Machine board game, just because You just never know what's going to happen. Okay, well, what about you? How did you solve it? What criteria cards did you pick, and in what order? And did you notice anything interesting? Add your thoughts to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to subscribe to not miss out on any future videos. Well, until next time, have a great one.